Alright guys, today we're going to work on rationalizing complex denominators, which says that if we have a problem with complex numbers and we're dividing, we do not like to leave this dividing by an imaginary number, because how do you divide by the square root of -1? That doesn't make any sense. So when we rationalize, we're going to figure out a way to get all the imaginary numbers out of the denominator so that we can divide both the real and the imaginary part of our complex number and just get regular numbers. Alright, so just as a reminder, we have a real and complex number. So the way we're going to do this, and this will work every single time, and I'll demonstrate this with variables, is we're going to multiply our complex number by the thing called the complex conjugate. And I don't know where this came from originally, but basically we're going to change the sign. We'll talk about more of the definition down here. So when we multiply complex numbers, don't forget that you have to distribute a times a times negative bi, positive bi times a, and positive bi times negative bi. So we're going to multiply those. A times a is going to give us a squared. And remember, a is just a number and b is just a number. A times negative bi is negative a bi. Positive bi times a is positive a bi. And positive bi times negative bi is negative b squared I squared. B times b is b squared. I times I is I squared. Alright, so we've got some middle terms that can cancel. A positive ABI and a negative ABI, we're just going to cross those off, and they're good to go. We also know that I squared is equal to -1. So a squared minus b squared, and we said that we're going to get,
we change I squared to -1, we're going to get a negative times a negative, which is going to give us a positive. And then whatever numbers these are, we can eventually just combine them. So here's the moral of the story. We have this thing we're going to use today called the complex conjugate. And the complex conjugate is just used to remove, among other things, it's used to remove imaginary numbers from denominators. And remember, our complex number has two parts. It's got the a, which is our real part, and the bi, which is our complex part. So this is our complex number. And then the complex conjugate is going to be given by a minus bi. And it's not a significant enough change, but it's a big enough change that we can use the difference of squares to get rid of that middle term that we don't like, with this I squared that we don't like. Okay, so this a minus bi is again the complex conjugate. Alright, so the basic, what we have to do, the only difference, a is still a and b is still b. The sign changes, that's the only thing. So you keep the same numbers, but to get the complex conjugate, you just change the sign of that second term, of the imaginary portion. Okay, so we just change the sign of the complex of the imaginary term, and then we're good to go. Let's do example 1 down here. Example 1 is 60 minus 25i divided by 7 minus 4i. So to get the complex conjugate, we're just going to multiply the bottom by 7 plus 4i. We just change the sign in the middle. And then we're also going to multiply the top by 7 plus 4i. And I remember from like radicals when we were rationalizing those, that if we multiply the top and bottom by the same thing, even though we're changing how the number looks, we're not really changing the number, because anything divided by itself is 1. So we're multiplying this number by 1. Alright, so let's multiply. We've got some multiplication to do on the top and some multiplication to do on the bottom. And don't forget, we have binomial times binomial, both the numerator and the denominator. So 60 times 7 is going to be 420. 60 times 4 is going to be positive 240, and then there's an I. Negative 25 times 7 is going to be 175, nope, negative 175 I. And then negative 25 times positive 4 is negative 100, and I times I is I squared. And we'll deal with simplifying that in just a minute. And then we'll do the same thing at the bottom. So we've got 7 times 7, which is going to give us 49. 7 times 4, which is going to give us positive 28, and then an I. Negative 4i times 7, which is negative 28i. and then negative 16i squared. And if you've done this right, these middle terms should be opposites, and you can cross them off. They are equal to 0. Okay, so simplifying. I'm going to combine my like terms in the top. I'm also going to replace I squared with just negative 1. So, sorry about that, folks. It's a little bit out of focus. So I'm going to replace I squared with negative 1. So I've got 420 in the numerator. 240 minus 175 is going to give us plus 65i minus 100 times negative 1. Again, I squared is equal to negative 1. All divided by 49 minus 16. And then this I squared is also equal to negative 1, so we're just going to multiply that as well. So let's simplify one more step. I notice I can make this a positive, so this is positive 100. So I get 420 plus 65i plus 100, all divided by 49 plus 16. And then we're going to simplify. One more step, we can combine the like terms. We get 520 plus 65i, all divided by, so you think 49 plus 16 is 65, which is very fortunate. Okay, so I'm just going to check. I know that I can reduce this fraction to 1i. I'm going to check what common factors 520 and 65 have. I wonder if it's multiple. Oh, they are multiples. Okay, so 520 divided by 65 is going to give us 8. It's going to give us 8. And then 65i divided by 65 is just I. So the simplified version of 60 minus 25i divided by 4 minus I is just 8 plus I, which worked out rather handily. Alright, so not all of our complex denominators will be addition and subtraction. So we only need to rationalize if we have an I in the denominator. So this I we have, we're going to multiply both the top and the bottom to get rid of that I. So I'm going to multiply the top and the bottom, switch my term sign for my imaginary portion, which is this is the imaginary portion. We don't have a regular number down here. So multiply the top and bottom by negative 3i. And there's a bunch of things you can use for this, but if you just want a hard and fast rule, just switch the sign, multiply it by top and bottom, and go for it. 5 times negative 3i is negative 15i divided by positive 3i times negative 3i is negative 9i squared. Okay, so let's cancel out the negative signs. We're going to have a positive 15i divided by negative 9, and then don't forget that, positive 9, canceled the signs out. I squared is equal to negative 1. So we're going to replace I squared with negative 1. So 15 divided by 9, they have a common factor of both of them. The greatest common factor is 3. So when I divide by 3 in both the numerator and the denominator, I'm going to get 5i divided by 3 times negative 1 is just negative 3, which says that the simplest possible form, the best way to write this is put the negative sign in the front. And I have negative 5i over 3. We successfully got the I out of the denominator. Woohoo! And I'm sure there's a faster way to do this as well. You probably could just multiply the top and the bottom by I. That would give you I squared in the bottom and prevent you from having to reduce. But, you know, hindsight's 20/20. Okay, so come get your practice. 4, we've got 5.2D, and then we'll get started. Thanks, guys.